On a coral reef, a small fish called a bluehead wrasse lives its entire life in a tightly organized group, one dominant male, and a group of females beneath him. If that male dies or is removed, something happens that shouldn't be biologically possible in most animals. Within hours, the largest female in the group begins behaving like a male. Within about 10 days, she has fully transformed, producing sperm instead of eggs, and taking over as the group's new male. This isn't a rare glitch. It's a normal, expected part of this fish's life cycle, and it isn't even the most extreme version of this ability in the ocean. Biologists call this sequential hermaphroditism, and it shows up across dozens of fish species in genuinely different directions. Bluehead wrasse and clownfish both change sex, but they do it in opposite orders, which is the part most people find hardest to believe. Clownfish, the fish made globally famous by an animated film about a father searching for his son, actually live in small groups led by a single dominant female, with one breeding male beneath her and several smaller, non-breeding males waiting in line. If the dominant female dies, the breeding male doesn't simply find a new mate. He changes sex entirely, becoming the group's new female, while the largest remaining junior male is promoted to take his old breeding role. If that original animated film had been biologically accurate, the father searching the ocean would have changed sex partway through the movie. The trigger for all of this isn't hormonal randomness, it's social structure itself. Researchers studying these species have found that it's specifically the absence of a dominant individual, detected through behavior, spacing, and in some studied species, direct aggression cues, that switches on the hormonal cascade responsible for the physical transformation. Remove the dominant fish artificially in a lab setting, and the transformation begins within hours, driven almost entirely by the social vacancy itself, rather than any internal biological clock. Now here's the part that's still ahead, and it's stranger than anything so far. Some species don't just switch once. The bidirectional sex-changing goby can flip back and forth between male and female more than once across its lifetime, depending entirely on which sex is more useful to the group at any given moment. That flexibility comes down to something researchers call the size advantage hypothesis. The idea that in some species, one sex produces dramatically more offspring at larger body sizes than the other does. In fish, where large females produce far more eggs than a same-sized male could ever fertilize efficiently, evolution favors starting life as male and switching to female later, once size allows for maximum reproductive output. In species like the wrasse and clownfish, where a single large male can dominate breeding rights and defend territory more effectively than a female of the same size, the advantage runs the opposite direction. The sex change isn't random. It's a body responding directly to which reproductive strategy currently pays off best, at that specific size, in that specific social position. None of this means every fish species can do this. Most fish are fixed at one sex for life, the same as most other vertebrates. But across the roughly 500 fish species where sequential hermaphroditism has been documented, the underlying mechanism is remarkably consistent: a social signal, a hormonal cascade, and a physical transformation completed in days rather than generations. So the next time you're watching a clownfish on a reef or in a fish tank, remember there's a real chance you're looking at an animal that used to be or might someday become the opposite sex entirely, not through anything unusual happening to it, but simply because the group around it needed something different. If your own body could switch roles that fast based purely on what your community needed, would you want to know the trigger in advance, or would you rather it just happen? Let me know your answer in the comments, and subscribe to NatureCrest for more deep dives into the animal kingdom's strangest and most misunderstood biology.